Smart contracts need to make decisions. Should this post be counted? Who won the election? How do we handle invalid inputs? Today we are learning control flow in Rust, the logic that makes a contract intelligent. We will build a voting contract from scratch to learn if-else, match expressions and loops. Every control flow concept will solve real problem. Let's start coding. First we need to write our library, this one, and after that we need to type the enums. Before going to the enums, first we need to write some requirements for them. Oops. And one more. Okay, let's write our enum. Vote choice. Just yes. Enum is like a multiple choice question. Our vote choice can be exactly one of these three options: yes, no, or abstain. Think of it as saying a vote must be one of these specific choices, nothing else. Let's write another enum. We'll just copy this one. Requirements for enum. Public enum. It will be active, passed, and rejected. So here you can exactly check the enum form. First, it declares a public enum type. Here is the variations, and need to mention enums force you to handle all possible cases, no forgetting edges cases. Before if else, let's repeat struct and initialization. Write our requirements for struct. Let's write the proposal title. It will be string. Yes votes. Today we'll use U32 because we don't need so large number as U128 and not so small as U8. For no vote the same type. Abstain identical. Voting deadline. Need to mention that about the time we write the number. It is pretty big, so we also use U32 for this. Also we'll write minimum votes required. It will be yes U32. And let's be final is voting open. And it will be boolean. So now our voting contract with vote counters for each choice, deadline and minimum vote requirement. This gives us a lot of scenarios for control flow decisions. Let's create our contract. It will be impl vote contract public function u and title. It's string as here. Deadline U32 and minimum votes U32, and we need to return the self. Also here self. Proposal title is a title. Yes votes will be 0 at the start. No votes the same. Voting deadline will have the deadline from the our function. Minimum votes required will have minimum votes. And is voting open, it will be true. There can be some problem with the struct to deploy in general our contracts. To avoid this error, we need to write this line. It just says that it's like our default struct, our default memory, so it will be no problems, no errors. Okay, let's start with a simple if-else statement for basic validation. So it will be public function is valid. It will be self as it takes some parameters from our public struct, and we'll put one variable current time that will be U32 as our voting deadline. If current time more self voting deadline. So if it's more, so it will be just false, and else it will be true. So let's explain the logic. It's check just one condition here, return different values based on true or false. In our case, if it's more, so it's return false, that it's not valid. It's very simple but essential for validation. Let's go for more complex if else. Again, we use self because we take some parameters from the our struct. Let's write current time one more time. It will be u32 and voter ID. And it will be string. And we will return also string. So let's type if self is voting open. Let's write like voting is closed. And here we need to convert it to string as we return string. Else current time, for example, more self voting deadline. So here we can write that voting deadline has passed to string one more time. If voter ID, if you want to check if it has no values, it's totally empty, we just write is empty and we'll write just invalid voter ID. Voter ID. And one more time to string. And let's write the final one. Else you can vote, so you pass all conditions. And never forget to string. So multiple condition with else if, each condition is checked in order. First true condition wins and returns the first one, or like by the order. And else handles everything that doesn't match. Perfect for step-by-step validation. When you have many specific values to check, match expressions are more powerful than if else. So let's create one more function to show it. Public function, and let's be process vote. Right now it will be mutable, so we will change our struct. Let's be choice, and right now here we'll write vote choice from here, and we'll return string. So here we'll start match choice, this one. Choice yes, and if it's yes, we'll write self yes votes just +1, and write for vote choice no. Let's write self no votes, and this should be +1. Choice abstain, basically the same. It's +1. So match expression backs is that here's a match, the value, each pattern have the action, what to do for each case, and must handle all possible enum values. Right now I will show you match with numbers and ranges. Function, let's be get participation value, participation level, participation level, self, and we'll return string. Let's calculate total votes. It will be self yes votes plus no votes, and also plus abstain votes. So here we'll write match total vote, the value, and right now if 0, we'll just write no participation, and of course convert it to string. If it's from 1 to 10, Need to mention, if you write like this, 1 to 10, it will be from 1 to 9. If you want to include the number 10, you need to write this equal here. For 110, let's be low participation. And to string, I don't know, let's be 11100. It will be medium participation. Participation to string. And we need to write the final one. This symbol means that it's everything else. So in our case, it's like everything that's more than 100. For this, we'll write high participation. Next, and the final one for the match, I will show you how to do the match with conditions. Public functions, let's proposal status. Take some variables from our struct, and we will return proposal status. It's enum from here, as you can see. Let's copy paste let total votes, and let's write match total votes more or equal minimum votes required. Self no votes. So here we need to write two conditions inside of this bracket. Here we can write, for example, false, and write this symbol. As I said before, it means like it doesn't matter for us. For example, if total votes less than minimum votes requirement, so it will be false. So for us it will be doesn't matter if yes votes more than no one. So here we just write proposal status active. If both is true, it will be definitely passed. If it's true and false, it will be rejected. Sometimes we need to repeat operations. Let's learn Rust loops types with simple voting example. For this, create one more function, public function, and let's just add yes votes. Mutable count u32, and we'll return string. For loop we'll write for n. You should write start with this symbol and some variable. It will be n, like the most common one. In from 0 to count, and it goes just from 0 to 1, 2, 3, 4, 5, 6 until the count. If you want, for example, do higher step or less step. So for here you need to write like this. Write step by 2. And here let's just add votes. Plus. Also in the end you can write how many votes did you add. It will be like this. Edit, brackets, yes, votes, and in the end count. So basically it repeats the same actions several times, and it's perfect when you know exactly how many times to loop. Let's add another loop while function count until majority. U32 mute count 0. We write mutable because we want to add to our count. Let's just copy total votes. That will be without abstain votes. And let mutable current yes. While current is let total votes divide by 2. So current yes we should add, and also add the count. And let's just run the count, because he has required that we need to return something. We will return the count. So we can delete this line and return current yes, because it will be the same. So while conditions keeps going while condition is true, and check condition before each iteration. Good when you don't know exact number of iterations, and be very careful to avoid infinity loops. And I will show you the final loop. Public find winning. Let's be let mutable number, it will equal 0, loop bracket, and if number equal 10, need to mention that we need to write not just one equal, it should be like 2 equals. It's really important because it will provide you an arrow. And if it's equal 10, so we break our loop, or we can, for example, just return the number. It doesn't turn. And if not, we just, that's now our number. Let's delete here and put it here. So as I said, like this loop is infinity one, so we must use break or return to exit. Also we can write continue, but it's, to be honest, not necessary at all, so you can just never write it, it doesn't matter. Let's quickly review what we learned about control flow in Rust. We learned enums, type safety, if else for simple decision, match for powerful pattern matching, loops just for repetition, and you successfully built a voting code that makes intelligent decision, validates inputs, and handles different scenarios safe. These control flow patterns are the foundation of all smart contract code. The link to the complete code in the description. Try to compile it, and I will see you in the next video.